Today, guys, we're going to be talking about a geotechnical report, what they're used for, why are we participating with them, what are the values, what information should we expect, what information should we not expect, and just get a general overview of a standard geotechnical report and how it can help us. These reports is probably the most valuable thing you'll have on a job site as far as understanding your soils and your conditions to help you prep your job. Uh, Today, this one is going to be more of a simple, basic geotechnical work. If you can do one of these, you can do, I would say, 40 or 50% of the reports out there. I will put on a video for ones that are more complicated, but here's a good one to get started and get the basics down and kind of understanding the flow. Most all of these reports are standard across the board. They will hit certain metrics. Who are we doing this for? Why are we doing this? What is the area? What do we see existing? What's underground? Why are we choosing to probe just these certain areas? And what do we recommend? What is the timeline? And maybe a referral back to liabilities and responsibilities, and then a final sign off with the detailed pages of what they found in the discovery process. Some of the other little nuances to a geotechnical report is to have agreements between, say, the contractor and the general contractor or owner, and agreements as far as terminology. What do we call rock? What do we call rip rock or partially weathered rock, PWR, or certain types of stone, because that can indicate densities in the rock so that we can know if we're going to have blasting or we're going to use a rock hammer or we can rip it out. All these things cost money, and we need to get the language down correctly, and so we can have them quantified and qualified so that we can have the correct understanding, so that when a deal's made, we can kind of stick to it, and then we don't have disagreements back and forth. So each one of those is helpful to break down in here as well. So as we kind of look at the first page here, obviously the person that was contracted or the company is GeoHydro Engineers. They're telling you that they have a report of a subsurface exploration, geotechnical engineering evaluation. So they don't worry about trees. They're not an arborist or anything else. They're just dealing with soils and anything geology, geo. Anything with the dirt, the rock, that's what they're looking at. And the groundwater, that's what they're worried about. Here's your address of your location so that you can tie it to a specific job for them, and the address of the located parcel. You want to make sure that this is the actual report for the parcel that you are on. You can verify that through the plans that you have and make sure they're tied together. And then they date it so that you know how old this thing is. So if there's been any kind of changes and this thing's 3 years old, okay, we might need to get an updated report. If you've seen there's property conditions changed, it's been cleared, there's been some dumping going on, there's been demolition that's happened, anything like that, we would probably recommend potentially an updated report to capture those nuances. So here we just got our first page that we're rolling into. This is who they did the report for, and a little bit detail on what was proposed. What are we planning to do here? So what the engineer has said, hey, here's my plan that I want to put on this job site. Would you guys go out here and do some investigation and find any potential concerns that we might have, or infrastructure issues, or rock elevations, water table, anything like that? They're trying to give you just a basic overview of what's happening. In each page, I would recommend just pause it and read through it. If you read these things just one time, you'll have it. It's not complicated. So there's a couple things like KIPS. Those are just pressure metrics. So a couple little words here and there you may not know, but as you read more and more of them, you'll definitely pick it up. They're not complicated. So they're very well spoken in these things, and they're pretty easy to read. Here we just go down and it just kind of give you some details. Soil test borings, And the subsurface exploration included 5 machine drilled soil test borings performed at approximate locations. So what they're trying to do is give you an idea of what did they use to test it. Was it a hand auger? Was it a machine? Was it a geoprobe? Split spoon? So there's different sampling methods. How far did they go down? Were they using generally accepted practices through the industry? Or were they just taking a pipe from Home Depot and a hammer and hitting it down in there and just seeing, hey, this is what I found, or a shovel? Did they go out there with an excavator and actually pot out holes with an excavator? We've done that before. So, how did they test it? What were they looking for? Some of the things that they found, things like that. Down here, you'll have infiltration tests. So, you're looking at percolation here. Percolation is, if I was to pour a cup of water on here, would the water just sit on top of the dirt, or would it actually just absorb down in there like beach sand? Or would it be like clay and just sits there like a little pond? All these factors matter. They tell you what's below the soil. It can be indicators. Also, if you're building a stormwater management plan and these soils don't percolate very well, you may have a situation where you may have to oversize your detention pond to accommodate that. If you get back-to-back storms and it goes in there, fills it up, but it's not going down, it's not percolating the soil, so they'll have to accommodate that so it doesn't overwhelm it. So when you're looking at geotech report, it's not just for us, the contractor. The civil engineer will look at it and determine, can it support the load-bearing pressure of the building? Can my pipe structures get in here? Can the stormwater, development plan, can they accommodate? As well as us for bidding purposes. So these are very valuable tools that we use to kind of help navigate a project. So we're going on here. Regional geology. This is kind of standard. So, the registered geologist here is going to, say, okay, if you're down there in Macon, you're in the Piedmont line, that's where it transitions into sand for South Georgia. You're in the Savannah district, or you're in the North Georgia district, where it gets you're on the foothills of the hills and the mountains and stuff. So, each one is going to have a regional Pacific style of rock. If you're in Gwinnett, we've got Stone Mountain over there. So, a lot of blue granite. If you're in North Georgia, you got that chipped slate that's up there. It's blue slate. Each one of them has different characteristics. So, they try to give you a regional area and a regional perspective of the area. To kind of enlighten you a little bit and give you a big macro perspective of the whole territory and what to expect. And so then we can just say, okay, well, this is not a site specific. This is generally accepted for this region. And then they have common rules and common baselines that are associated with that region. So in the Savannah district, or say you got Macon, footings are with certain bearing pressures. So those actually, everybody knows, this typically works in this area. Up here, this typically works in this area. So it gives us a range of understanding of what's going to likely be the best conditions to put our building on. Let's see. We've got a little summary. So they're just giving you a basic overview. You can read through these. They're pretty good to just kind of get a good understanding of what's happening. One of the things I want to maybe, you're going to see this quite often, partially weathered rock. That is essentially, if you took an excavator, say a 200 series, and you can scrape it with your teeth and it would almost chip out, and you can grab it by the grain and pull it out without breaking the bucket, that's called PWR. Usually you'll have a subsurface started out, and you'll see the soil colors change, and you're going to see the PWR start coming up, and then you'll start seeing some quartzing, granite, and some slate down through there. But it's usually an indicator of the top layers of the rock, and it's usually a softer rock, but it will get denser as it goes down. You're also noticing like B1, B2, B3, or not B2, B3 here. Those are borings. So a boring is nothing more than a drill going down and boring through there. Just a fancy drill is all you want to think of. And they're labeled out there, B1, B2, B3. and their references. And as we get down in this report, we'll have the reports to it. If you're walking a job site, you're more likely going to see about a 4-inch hole, maybe 6, but usually 4. And you're going to see the soil piled up beside it where they pulled it off the flights of the auger bit. And, usually there's a pin flag. Sometimes they'll have the engineering firm labeled on the pin flag, and they've written on it B1, B2. So when I start a site, I usually like to go find these areas, and I can actually grab the handful of dirt that came out of that area, and get a little deeper understanding of what I've got going on. So those are really good things. When you get this report and you're starting a job, read the report, go out there to the job, try to find all your boring locations. The map is usually pretty close to where they're at. Just usually look for a little pin flag, usually a pink flag with the B1 or B2 on it, and you can look at the soil and then look at the report and kind of get a better understanding, because you're looking at the conditions, you're looking at the report, and things start tying together, and you and the operators and the foreman can kind of get a better understanding of what are we going to be contending with, and what are we looking at. What you're looking at here, when it says 5 to 34 blows per foot. So I just want you to think of, if you've got a piece of hard oak or any dense wood, and then you've got a piece of balsa wood or some very soft wood. If I was to take a hammer and a nail, and I've got a regular 16-penny nail, and I drive it into that balsa wood, I'm like, dunk, dunk, and it's in. If I've got a hard piece of oak, it may take me 6 or 8 hits to get that nail in that board. So the more dense a ground is, the higher the blow count. So it took me, to get through this 1 foot of dirt here, it took me 15 blows. Okay, that's medium density. Or if it took 3 blows, like I'm in sand, and dook, 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 and it went down a foot, that's soft stuff. So the blow count can tell you the density of the soil. And when you start excavating with an excavator and you start, having to really work that thing, you're going to know that those blow counts are higher. And you can kind of anticipate that. And this will help you as a foreman or an operator kind of be predictive and say, how long is it going to take me to load these trucks? Well, my blow counts are in the 25. That's pretty tight stuff. And I know once I get down to this elevation, I've got PWR close by. So you can be talking to the GC, you can talk to the foremans, guys can communicate and really set expectations so that you're not pushing your schedules in behind and going, oh, we're going to be done in 2 weeks, and it's actually another week and a half after that. This will help you kind of do a predictive analysis there of it. So here we've just got our graph. Here these are their borings labeled out. The ground elevation, that's the elevation above sea level. So that's where we're starting at. Okay, that's our initial 949. Where their elevation, their depth, they went down 6 feet. Here they went down 3, 6. So these are pretty shallow. Most borings will be down maybe 15, 20 feet, on average 10 feet most of the time. If we got some heavy cuts and fills, but they didn't see necessary that it went more than 3 to 6. Let's see here. Bottom to fill. Oh, to fill, that's what it is. So the fill is going to be 6 feet here, so there is a good bit of fill. But they actually went down 17 feet here. And we'll have to see, not encountered there. If you'll notice, I went right down to my reference here. PWR, partially weathered rock. Auger refusal. Refusal means that essentially they got down on some hard stuff and they hit stone, rock. They were drilling it and it just would not go through. So they just put auger refusal. So they didn't hit auger refusal here, or they didn't put not encountered there. Approximate. So bottom of fill. So there were some soil brought in here. 6 foot of fill, 3 foot of fill. Something's happened on this site. So we're not dealing with virgin dirt. This is not just some woods that nobody's touched. Somebody's been down here working on something. Let's see, top of PWR. So they did hit some rock here at 932. So they were at 949 on the top. So down there a pretty good bit, 17 feet. They hit the rock. So I want to make sure none of my storm or none of my detention pond is in that range right there when I'm going back to my report. They actually went down 25 feet here. termination, and that was the elevation that they went. So they did actually go pretty deep here. There is an asterisk right here, which that means auger refusal right there. So they did hit rock down there at 32 feet, which is understandable. I don't think we'll be going down that deep, but we'll look on the plans to find out. One of the other key features here, remember this is a legal document here. We've got the date here when it was done and the page number. Okay, so when you're out there, make sure you're looking at it and the dates are consistent and the page numbers are, so that you're not missing a page potentially out of your document. So let's see what it says here. Evaluations and recommendations. So part of the geotech report is they're going to say, hey, this is what we think is here and what we think needs to get done in order for you to get your project done. So we've got a couple of recommendations here. All the test borings encountered fill materials extending depths of ranging of 3 to 6 feet. We expect any fill encountered on the site during construction to be highly variable. So they're already telling you, guys, go ahead and tell the customer, we don't know what's down here. Let them know. And some management of poor quality fill material will likely be necessary during grading. So I can already tell you, that tells you right there in the pre-con, before we even start the job, we're having our meeting, the geotech needs to be there. And when we start hitting in this section, that they're going to be monitoring it. So we as the grader can now just say, oh, that's bad dirt. That's not our job. We push it, place it wherever they want, but we don't decide how much goes there, on how much gets out of there, and we don't qualify it. That is a professional civil engineer tells you how much, or a surveyor, and then a licensed geotech will qualify it. So they'll tell us all this. So you can see they're already throwing red flags right out of the gate that, hey, we need to be here. We need to be monitoring this. We need to see what you're doing. So just don't start pulling out dirt. Have the geotech monitor this situation. I would definitely, if I was out there running the job, I would be highlighting this area and make sure all the guys knew it. They were very well versed on, how to handle the geotech, stuff like that. Let's skip down. I'll let you read that. The test boring indicate generally favorable excavation conditions. Fill and residual soils should be readily removable using conventional soil excavation equipment. So they're saying, hey, these residual soils, these have been here for a while. We don't foresee anything that you'd have to get some big giant excavator. Just the standard stuff will work fine. And these guys are in our business, so they're what they say is pretty good here. Such as loaders and backhoes, partially weathered rock PWRs was encountered in boring 1, B1, B3, and B4 at depths ranging from 17 to 27 feet. Although we do not expect, I'm not saying it's not, excavation from this project to extend to those depths, it is important to note that the depth of rock, partially weathered rock, may vary drastically over relatively short distances. So the geotech essentially saying, hey man, we didn't hit any rock, but I'm not saying there couldn't be any rock. And in this area, it could jump up and you could be on top of rock and you not even know it. The geotech can punch this thing like Swiss cheese, but the owners don't want to pay for 200 borings. You got to we're just looking at reducing risk. We're not trying to eliminate it and spend all this money. So, you can turn that thing into Swiss cheese, but it just doesn't make economic sense. So they're saying, hey, this is our best judgment here. We're trying to reduce the risk. This is what we highly likely think is here. Let's say, and it adds to it, it would not be unusual to encounter partially weathered rock lenses, rock pinnacles, or boulders between the around test borings. So ripping and the use of impact hammers are typically required to facilitate excavation of PWR. There's telling you. Put the hammer on it, put the ripper down, and let her go. In some cases, blasting is required to excavate very dense PWR. Let's say, at the time of drilling, groundwater was not encountered. Big deal right here. It's highlighting. It was not encountered. I'm not saying it's not there. It was not encountered. Which is a good sign. We're not having to deal with groundwater. For safety reasons, the borings were backfilled after initial groundwater level measurements. Now remember what I said earlier. Sometimes you got there and find them. Well, they went so deep, they didn't want some kids or anything or animals getting falling down in there. Out of a ditch one time, I've saved 2 times. I actually saved baby deer. So squirrels, chipmunks, you don't want anything falling down in there. So sometimes these guys will backfill them, sometimes they won't. You can still look at some of the residual soils because it doesn't fill it all the way back up. But when you're walking out there trying to find them, if it's filled in, you won't be able to see too much. All right, it should be noted that groundwater levels will fluctuate depending on yearly seasonal rainfall variations and other factors that may rise in the future. So if you're in the wintertime, water table is likely to be a foot or 2 higher standardly than what it is in the summertime. It usually drops in the summertime. Wintertime, it comes up. So water table is just a consistent, level of water that's in the ground. If a stream is at this elevation, it's usually 20 or 30 feet across the board, all the way up under there, and whatnot. So if we run into that, then that's the time we have to get pumps and other things out that we have to think we're laying pipe, or if we got a detention system. Let's see, what do we got next? Based on the results. Based on the results, they're giving you information. This is for the civil engineer, 300 kips. This is going to help the engineer determine how big his footer's got to be, how much rebar, what kind of concrete to use. Just some standards to say, hey, this is what you need to do in order to support your building. Based on the results, the test boring is following the calculation procedure, the 2018 International Building Code. So you see what they're referencing, all this, and this. This is what we're basing our information on. This is what we're based our recommendation on. These other people. Okay. Let's see. General site prep. The remains of a former structure. Red flag right there. We got somebody demoed something, but they didn't clean it all up. So we got some remains. So I can already tell you, I see that and hear that. I'm going to go. We're going to need a roll-off box. And we're going to have to get rid of some debris, I'm sure. How much? I don't know. But I can already tell you, I'm going to go ahead and call them a roll-off company and get them on standby and get a price and get that worked out. So the remains of former structures and their foundations, any vegetation, roots, topsoil, demolition debris should be completely removed from the construction area. Clearing, grubbing, stripping should be performed only during dry weather conditions. Operation of heavy equipment on the site during wet conditions could result in excessive rutting, mixing of debris, and topsoils and underlying soil. Essentially what they're saying is, hey man, this thing's likely to have a bunch of junk and other stuff. Let's not contaminate the good soil with the bad soil. So when it's dry, let's strip all that stuff off, consolidate it. Geotech will come out there and qualify it. If it's outside the norm of standard roots and tree debris, the geotech will qualify that. We'll take those to the C&D construction demolition disposal facility, and the regular tree material will isolate that over, and that should be within our contract ideally, and that'll go to the inert facility, which is going to be all organic stuff that can rot and take care of business over there. So they're already kind of letting you know, hey, do this thing this way. This is how we want it done. We recommend that the areas receive structural fill to be proof rolled whenever possible. So these are areas that are going to be anything in the roadway, parking lot, building footprint, anything that's holding up some kind of structural footing per se, or heavy load. If it's in a landscaped area on a hill slope that's going to get some bushes, it's in between some islands in the parking lot, or if it's behind some curb, they're not worried about this. So anything that's going to receive the structural fill or be a part of some kind of structural integrity area, they're going to require that. So a proof roll, it even tells you here, tandem axle dump truck weighing 18 tons. If you're the driver, you're going to be putting in low, super low, and you're going to be creeping down through there with a full load of dirt, and the geotech is going to be witnessing, and you're going to be watching. The foreman's going to watch. And they're going to walk behind the truck. And they're going to be looking for what I call mattressing or pumping or settling or squishing or anything like that before anything is filled above that. Again, you can put a slab of concrete on top of a mattress, it's still going to wiggle. So we want to make sure our base is tight, and if there's any problems, let's remediate them, fix them before we start placing fill. So they're recommending a proof roll and all that. And proof rolls are also done at the final stage too, and along the way. Whenever you're doing proof rolls, just know the geotech has to initiate and tell the driver they're in full control of the driver. Now, we as a company, we understand everybody's looking at back tires and not at being visually aware of the area. So we want to actually have a safety meeting before we do a proof roll. Who's directing the driver? What areas are we planning to proof roll? We shut down those areas, and we kind of just be a little high alert on those things, because everybody's micro focused, but they're not always macro focused. And like I said, just read through this. It'll give you some details on things that they've maybe have encountered and whatnot. So it'll give you an idea. Let's see. Existing fill materials. So whenever we hear fill materials, likely this was somebody just dumped some dirt and slicked it off. So it wasn't checked on the bottom, properly tested along the way, or the dirt wasn't tested. So usually these soils are not up to the standards that a commercial property would need to be, or even residential properties for that matter. So and the higher the profile of the project, the more clarification and verification we need on our dirt. So they're telling you, we've got 3 to 6 feet of this stuff. So I can already tell you, we've already prepped a customer reading through this that a lot of the soil is going to have to be removed, hauled off, or placed in some landscape areas outside the structural area. So we've tried to already put that in the budget so that when we hit this, we've already been aware of it, and we're trying to manage it and mitigate any further cost or downtime. Let's see, excavation characteristics. For this one, the test borings indicate generally favorable excavation conditions. So they're saying, hey guys, excavating contractor were pretty good, shouldn't be any problems. Fill materials and residual soils should be readily removable using conventional soil excavation equipment. That's what they kind of described earlier. For construction bidding and field verification purposes, it is common to provide verifiable definition of rock in the project specifications. So when we do a bid, we will sometimes copy and paste this or have reference to the geotech report on this page here, and just say we are in alignment with what they define as mass rock and what they identify as trench rock, so that we're on the same page. And we can all qualify it, and we've got a price associated with this, and we have a price associated with this. All this stuff should be agreed upon on the front end, not as you're trying to negotiate in the middle of finding the rock. So it keeps the crew rolling, and we need to do this as preventative and not in a reactive state. So get everybody on the same page. Obviously, some of the older, I've noticed some of the older firms, they have not updated their equipment numbers and stuff. Some of they're using excavator numbers from the 80s and 90s. But this one here's got like a PC 220 LC7, the 230C John Deere. These are newer ones, the 322C. So, the horsepowers and stuff, bucket widths. So they've updated those. So you need to know your numbers on what a Deere 230 is and about what it can do, or a PC 220 Komatsu. When we're bidding, that way you can get the general expectations there. But most of these PC 220s come with a 42-inch bucket, or in the 36, 42. So they're within range. And that's pretty standard equipment. Reuse of excavated material. So we pull some of this stuff out, can all of it go back in? Well, that's not always the case. The general rule of thumb for me, if it's rock, and what my geotechs have mostly told me, that it's got to be within, if it's rock, it's got to be smaller than, say, cantaloupes or grapefruits. That way you can get it compacted all the way around it and don't have any settlement issues. But again, that must be qualified by the geotech. So if you want to know if that material is suitable for backfill, ask the geotech. They are there to recommend and tell you and direct you on what to do. A lot of times they'll give you 3 options, and if it's a change order, one of the 3 options, we in the office will price those things and get the owners a feedback and see which one they want to move forward, and then we'll pick that decision and move forward. But again, rely on the geotech. Now, in reference, the geotech works directly for the owner, not for us. So they are there to be a representative of the owner and be on their benefactor. Let's see. So pause and read that. That'll give you some good detail. Structural fill. How do we determine structural fill? How do we label it? How are we defining it? Same thing. Let's get on the same page with our definitions. Groundwater. What do we label as groundwater? Where was it? Did they find anything like that? So they're going to give you some details there. Earth slopes. So just slopes, general condition. Just slopes, okay? Temporary construction slopes should be designed in strict compliance with OSHA. So look, guys, we've got to stick to our standard stuff on slopes. Anything over 2 to 1 is going to have to be mechanically held back structurally. So either soil nail walls or MSE modular block walls, stacked stone walls, poured what they call cast in place walls, poured walls. It's going to have to be, and they'll go through the description here and what you can and can't do in these certain soils. So if you're laying it back for pipe, the geotech's there and say, hey man, I know soils, and this soil's, you're going to have to lay it back a little more because it's going to slough on you. Or this soil here actually, for this wall, and you're wanting to do your cutout and you're hitting your limits of disturbance, you can actually steepen that wall up and you're going to be okay. But you've had a registered professional talk to you about that soil. So we don't want to take on that risk and liability. Bring in the team, bring in the meeting of the minds, and everybody look at it and determine what's going to be best for the project and keeping guys safe and keeping the soil stabilized. Let's see, cast in place structures. There, we're rolling right into it. So if there's a cast in place wall on this job, here's the mathematics that they're going to use to determine the footing size, how big the wall needs to be, how thick it needs to be, what kind of concrete it needs to be. They're going to determine all that. We don't have to use that a lot, but remember, this tool is not just for you, it's for the civil engineer as well. Foundation design for the building. They're going to give you recommendations on that, the pounds per square foot here. So the concrete detail is all good, how they determine the width of the footer, the height of the footer, how much rebar, all that, the kind of concrete, all came from this information here. Seismic. So are we in an earthquake zone? There was one time I had an engineer that was from California, and my God, his footers were horrifically huge, but he had been in earthquake territory, so he kind of built everything for Georgia, as far as we were concerned. Earthquake is a real thing, and if you're dealing with a really large building, multi-story, this is big stuff. So if you're dealing with a single-story little warehouse shop, it's not that big a deal. But these things all are, the geotech is looking at all these details. Floor slab subgrade preparation. So when we are going to prep the subgrade for the slab, we're going to read this and understand exactly what they're planning on doing and expectations they're going to have, because we don't want to get come out there and say, oh, we're ready, and they test it and it's like, guys, this is not what we had talked about. So read that section. It's very important to understand what you're doing. Let's see, moisture control. So if you've got water tables that are fluctuating up and the ground is starting to wick up the water, you don't want to have all that moisture coming into the bottom of your slab and causing mold and mildew issues or anything like that. In certain sites around here, we've had to make sure we haul in 57 stone and plastic for radon. It's a gas that comes out of the soil. It's in high rocky environments. So moisture, any of these things, they're going to start, being important for us to understand. Let's see, flexible pavement design. So we're not dealing with concrete, we're dealing with asphalt here, so it's flexible. So these soil conditions we can accommodate with this type of asphalt, this much GAB, this much binder, this much topping. This is what we recommend will hold up on these types of soils. Let's see here. Pavement materials testing. So, let's back up here. Pavement design limitations. They've got some italics right here. So anytime I see that, I'm going to stop and pause and go, let's look at this. So the pavement sections discussed above are based on our experience with similar type development. They're just saying, hey guys, this area, these type of buildings, this type of traffic that come in here, this is what generally works. We're not guaranteeing you this is going to work perfectly, but you got a high likeliness it will. Let's see, pavement materials testing. So they're going to test the density testing subgrade materials. So you already know you're getting a test right there. Proof rolling. The GAB is going to be tested. The thickness is going to be tested. So there might be coring the asphalt. So don't leave your grade too high in there and you're a little thin on your GAB, but the top looks good. When they core it and they find out you only got 4 inches of GAB and you're supposed to have 6, you got to pull it out. Or you're taking responsibility, or we are taking responsibility. And you're increasing your warranty. So let's see. So now we've got somebody that is a staff engineer. They are a registered engineer. He's a chief engineer, Lewis. So if we have any issues, let's see. He's a staff engineer. So John probably did it. And Lewis ended up looking after them, making sure they were following the details. But this is probably likely who performed all the work. But this is the one that's signing their name to it. This is the liability person. So if we have any troubles and concerns or questions, we're going to talk to John and see what he can do to help us out. And before we get to pre-con, we're gonna hope that John's going to be there and talk to us and give us a little detail. If not, they'll have one of the reps there. So let's go on down. Now we're getting into the good stuff. If you'll notice how they structure these things, they put a lot of the major detail in the front of this thing and break it down accordingly. So they've got a system for working you through this project, okay? Follow the system. Don't skip through this thing and go all the way to the back. It's very easy for field guys and whatnot to go all the way to the back and just start going into the detail of the paperwork. And you'll see that here in a minute because it's easy to read. Get the other stuff down, okay? Read it top to bottom. It'll save you. So the first page here, we've got our north here. So when we get out there, we can actually adjust the plan and get ourselves positioned and know exactly what we're dealing with. We've got our scale. You want to verify from whoever printed this thing that the scale matches. So do a scale verification. Let's make sure that the address is correct. Everything's good there. And here we go. So we've got the borings here labeled out. I see an icon for the red here that matches here, but I don't see one for the blue. So I might email John up here, unless we can find it. John, I might send him a quick email and say, hey, request for information, RFI. Can you tell me what these two blue icons mean? I'm not seeing them down in the legend. Maybe we find it here in a minute, but I'm going to put a mental note right there that I need to follow up. So we obviously know that they've got a hard concentration of borings right here, but they don't have anything up here. So the geotech probably noticed no problems or no issues, no red flags up here. But man, they were really concerned about right here. So that trash debris, maybe in the low area or the fill of the dirt, this is towards the back of the property. So this may be in a little dumping ground. I don't know. But I can tell you, that's telling me they got some red flags over here. So when we go out there and walk that site, I'm going to pay close attention. I'm going to take good attention for here, but I'm going to take serious contention right here about this. So here we have our symbols and nomenclature. So You'll want to know these. These are really important. Like these right here with the water level, it's super important. This is a standard one across the board. Know this one. Know the GW, groundwater. Okay. These are kind of industry specific to these guys. And fill, residual soil, PWR, all these are pretty standard. But I'd say if I was just to look at this, I'd say, you know, a lot of these are pretty common, but the most common ones are these. I would definitely know these 100% right here. These here, you know, that one's pretty common when you're doing the blow counts. But these other symbols, they sometimes move around depending on the geotech. But these right there here, yeah, know them really well. This is a very important section right here. So this is what I was talking about, the blow counts. So penetration resistance results, number in blows. This is kind of N value there. So like I say, if they're trying to go for a foot distance down through there, very dense. You're hitting 50 blows. So that's 50 blows. Doom, doom, doom. And this machine has got a pipe that's going down through there, taking a core sample, and it's got a big weight up above it. And it slams down on it consistently. It just drops. They have a rope that pulls it up, and then it drops. Pulls it up, and drops it. And the geotech sits there and just counts. 1, 2, 3, 4. So until it meets a foot, then he marks it down on this report. Here, you can read how they perform their procedures here. 140-pound hammer, falling from 30 inches, 2 inches over OD diameter, all that. So just read that. It's very important. It's a good thing to learn. So here's our little holy grail here. This is the B1. This is our boring log. So the first things that we'll come to is this is B1. This is a test boring record, and this is who did it. This is the actual job, location, methods. So you can actually look this up and reference these methods right up in here. So if you notice ASTM, these are just standard processes that are across the board. So another firm is going to use that same kind. They should produce the same results. So let's see. We've got the driller. So Freedom come out there. That's the company. They used an auto hammer, GLS, elevation, the date, project number. We've got it 24 hours, backfield, nada, not encountered. All right, so now we're going to go down the side here. The side here is your elevation above sea level. Okay, this is your depth from surface right here. So this one, they went down 25 feet. The elevation would be somewhere around 924 there. When they started, you're going to be around 46, 47, 48, 49. So 949 is where they started. These symbols are kind of important. They range a little bit, but they have some standard practices. I wouldn't say it's 100% across the board, but most of them are pretty standard. But it's really, in your mind when you're reading this thing, just know that this is different soil type. This is another one, and here's another one. So when you're digging, you're going to know, okay, if my pipe's at the bottom elevation of my structure's at 936, I'm going to be in loose, firm, tan, mica type soil, silty, fine sand. But if my bottom of my pipe structure and whatnot is down here, you know, we're probably going to hit rock on that structure. We need to go ahead and get the hammer hauled out there and be on standby, or at least make some phone calls and have the geotech present. And then have a plan B, so when we got our crew standing around, they could be working on something else. Or have a geotech ready to have answers, or we got ready for the superintendent to have a time material sheet ready to go. All this stuff can be agreed upon. So once we hit it, we can reach over there and grab the hammer. Geotech says, yep, that's the rock we thought it was. Superintendent says, yep, we agreed upon it. Start the time clock, sign your paperwork, get to rolling. Doesn't have to wait a day or two to get answers. Okay, moving across here are N values. What you're looking at is your blow counts. So in order to get down here, we have an 11. So those 11 hits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? So making sure that you kind of understand these graphs. When the graph's going back this way, it's soft. When it's going back over there, it's hard, soft, hard, harder, very hard. You can see here, look, they hit this one, it started tightening up. So you're going to have to hammer that stuff or blast it. This stuff is not going to be scratched out likely when you're hitting that many licks. So again, same stuff. We'll go through, this is going to be on B2. Topsoil, approximately 3 inches, so not much topsoil. Firm red brown there, sandy clays, stiff red brown. Then we got pretty good soils all the way down, 35 feet. We're good. Density is medium density here and get a little denser as we go down. But if you go back up, remember that if I didn't pass it, the numbers on your density here we go, that are 11 to 20, and we're right there in the firm category there, firm and very firm. So most of our stuff is loose to firm. So when you're talking to your geotech and your foreman and all you guys and the superintendent are out there talking, you guys can look at the report and say, all right, we already know we're going to have loose soil here. Is it loose because it's poor quality of soil, or is it loose because it wasn't well compacted? Now, loose soil can also indicate a sponge for water, and so high moisture content. So they can cook the dirt and tell you the moisture content. You may pull that dirt to the side and let it be drying. Any of that loose stuff, let it be drying. Have them check it and find out, what's the quality of it. Again, same stuff here. Auger refusal. We noticed that in the other report up above. No remarks. Pretty simple. Same thing here. Blow count's pretty good. Soft material all the way. For some reason, there was a really tight layer and then it loosened up. So sometimes that's a little bit of red flag. Sometimes you will hit rock here and it'll be like a layer that holds the water up, and you'll see the water table right in here, or it gets really soft before it gets real hard. You would think logically it'd just get progressively harder. It doesn't usually work that. It's kind of something that starts out hard to soft and then back to hard. And the density ranges. Here we're pretty consistent all the way down. So this area here, we might just be kind of wondering what's happening here, but it was consistent. So there it goes down to B5. Again, I didn't see the confirmation, so I would be sending the geotech and RFI, request for information, on what these blue icons are here. I could probably spend some more time dig into this thing and find it, but I feel like we get a good college try to go through here. I would just send them an RFI and say, or give them a phone call. I need to introduce myself anyways if we've got the project, and find out what the details are here. But as you can see, this is a fairly simple one. GeoHydra is one of the big major ones in the Georgia area. So you'll likely see those guys. But anyways, the structure is very consistent with these reports. There are some that are more complicated, and I'll do a video on one of those later. But for the most part, this one checked all the boxes. They are industry professionals. This is what you're going to see. This is what you're going to engage with. I always had a very close relationship, even closer to the civil than the civil, was with the geotech. I always had a very close relationship with them, always do, and they become friends. So you'll get their phone number, pass back. The biggest thing you can do for them is give them heads up notice of when you need them, and what they're going to want. They also can help find details in the plans and work with the civil. So you as a contractor may not know what to do. You can get the civil on the phone and the geotech on the phone, and then let them work it out, and then they can tell us together what needs to be done. That's just a brief overview of a geotechnical report. Again, if you have any questions, feel free to reach out to me. I'll be glad to answer anything, and good luck to you. Thank you.